Greetings and welcome back to the lab. Time for, I guess, the second part of this series where we're going to talk about the big clock. And I've had to think through some things and trace this circuit board. Here's the other circuit boards that would be involved. I want to start building. I have not finished the 3D printed case because I'm trying to figure out how exactly I'm going to button it up in the back. I'll put up a render here so you can now see how I have posts to handle. Actually, these were in the wrong orientation to handle these. And then I'll just push them up against there. There we go. And then below that is going to be this. Something like that. And, except I got that upside down. And actually, this will be upside down like that because I want to have this facing forward for the actual display, but in the back, I want to have the ability to put the LEDs in so I can see what I'm doing while I'm connecting. Well, let me flip it over. Connecting these connectors for the display over to the connectors on this side, which will actually be on, if this is up this way, then these will all be backwards. And so we'll be connecting into these strips here and to a lesser degree, those strips there. So I've been trying to figure it all out. And what I've come up with is that I'm going to build this first here, except what I'm going to do is put pin headers for the display so I can plug in the display to make sure it's operating the way it's supposed to. But then I can pull them out so it's not drawing too much power away from this display, because if I run them both at the same time, it's all going to get very dim. I also need to figure out the resistors that will control basically to control the brightness of the display. So I'm not going to use the values that are already on here. So in order to do that, what I'm going to have to do, I was going to put pin headers, but it's not going to match up. I'd have to put one individual pin header for each resistor. That's just too much. So I'll have to figure out some way to probably from the back, since this is only technically a one-sided board, because the tracks only run on this side of the board. And I'm going to have to figure out some way, because those resistors are going to be here now, to probably just hold a resistor on there so I can figure out if it's the right brightness. Once I know that if I put a resistor there, that it'll light up, say, this one here, then I can flip it back over. I can put the resistor on and watch this display here, because if you see, they'll coordinate this one with that one, middle one with that one, the right one with that one. So that's what I'm going to have to do. So I'm going to build this out as much as I can with pin headers, which gives me the option to be able to control things and decide on which resistors I need here, which resistors I need here. Now, these resistors over here, most of them anyway, are for when you wire up an LED, you get, say, 5 volts, because there's actually a 5-volt regulator right here. Like I said, I've kind of traced this out. It didn't come with the schematic. I traced it out, and so there's a 5-volt regulator here. So the 5 volts is going into one end of this resistor. Then it's going through the resistor to the transistor here, which that transistor is then switching on and off the segments of these different displays. So I got one resistor here. I got another resistor which controls the possible output from the transistor. Basically what's happening is this chip can only drive so much power into the rest of the display. And so you have to set this according to what that will be able to handle. But then if you want more, you're using your transistor to amplify that signal so that you can get it brighter over here. So I have to figure out these resistors. I have to figure out these resistors down here, which go with the transistors. Some of these transistors go to the segments of the display. And a couple of them, or I guess 3 of them, are going to go to, I want to make sure I say that right. Well, we'll come back to that eventually. But 1, 2, 3, 4, 5, 6, 7. There's 7 transistors. That's your 7 segments. You've got to also have the ability to switch on each individual 2-digit display, because ultimately what it's doing is called multiplexing. And the multiplexing is to say that you don't turn them all on at the same time. You turn them on and off, but very, very quickly, so it looks like they're on all the time. And that way you're not consuming too much power coming out of this chip or going through these resistors or going through the transistors. You're conserving power by multiplexing, so that basically what it's going to do is it's going to say, okay, I'm about to do the first digit. Which segments should be turned on right now? It'll turn on all of those segments, and then it'll switch that first digit on. And then it'll move over to the next digit and say, which segments do I need to turn on to make the appropriate number there? And then it turns that one on. And it gets through all 6 of these before this one flashes off. So it's called persistence of vision. So that's what they're trying to do. And and it works. It's proven that it'll work. So I'm going to have to do the same thing up here. I'm not sure. That is one question, is whether or not the amount that I'm trying to pump in here is going to be enough. I need to pump in more power here because, well, actually I may not need to pump in more power. The thing is, if I have just the one segment, say the very top segment on the first digit here, if I have that turned on, that corresponds to these 4 LEDs. That's one LED. These are 4 LEDs. So if I wire these in parallel, the voltage would be the same, and that's fine. But ultimately, I have to share the power amongst the 4 of them. So basically, you're going to take whatever power is available, divide it by 4, and that's how bright these are going to be. They are bigger. They are possibly a more efficient solution, depending on how you look at it. So ultimately, we're going to have to figure all of that out. So the beginning step is I'm going to have to go through here. I'm going to put pin headers here, 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 here to be able to handle those. I'm going to have to leave these open here, leave these open here. I'm not going to, I may actually put a pin header for the buzzer, but ultimately this one also has a feature of, if you want to use the alarm function, there's an input and an output. These 2 connectors here. Also, another nice thing about this is they wired up the switches backwards, S3, S2, S1. So if you ever read the instructions for how to actually set the clock, it talks about S1 first, and then S2, and then S3 will change the minutes, and then whatever. I'll pull up the instructions at some point and show you how to do all of this. But if you imagine that's 3, 2, 1, if I flip it over so you're setting the clock, it is now 1, 2, 3. So that's going to work out kind of nicely. You'd be reaching back and finding the buttons with your fingers, but ultimately you'll be able to set it and it'll make more sense. That said, I think it's time to start populating the board with the components that I don't need to adjust and getting pin headers on everything else that I can. I'll get the transistors in here. I think that'll be fair. And the capacitors are going to be fine, and the regulator will be fine. So I think I'm good putting all this together. That is the plan. And that was just the introduction. In the next episode, we'll actually build. Thank you so much for watching.